Okay, so let's proceed. Now, when we try to study minerals, that is already under mineralogy. And why do we need to study minerals? First and foremost, because they are the building blocks of your rock. Now, in our face-to-face class, we have a lot of rock samples present. And when we will have our lab, makita ni mo class that most of those rock samples actually have very distinctive na mga mineral composition. Makita nimo na siya nga naagyo'y lahi-lahi color, lain-lain og shape ang iyang crystals kay dagko na po'y crystals na gagmay and naapoy siya mga murag mga dust nga na napilit sa imong mga rock sample. So makita na to na og ma-realize na to na that our rock is actually made up of your minerals. So basically, if you have say tawag ani, I'm trying to make an analogy with your bio since you have a bio class. Ano no? Wala kaya man din yung inyong kuano isa ka IS karon. So anyway, forget about it. So one of the things that we have to think about when we deal with minerals is the fact that they are highly linked with our very existence. Labi na sa atong technology, infrastructure, and everything. So why technology? Of course, the very material na ginagamit nato sa atong mga microchips, of course, has to be mined. And they are considered in geologist's perspective to be minerals sabto sila ilabi na katong i-extract pagyud gikan sa ore. Now, these are just some of the minerals na ginagamit nato. So, kana sila. Now, on another note also, if we try to look into or try to put our discussion in your, I know you have your class with ma'am on I think it was on geography and trying to understand the history of the human race. So kabalo kita na class na there was significantly a giant more like improvement in the way of the lives of our ancestor when they discovered bronze. So 'di ba ang bronze nimo imuha na siyang gina-combine from copper and tin. So naputay brass. So it's already an alloy of several na mga gipang mine na to nga mga elements together. And we can't deny the fact that because of those discoveries, may progress yun or naay significant na development ang ato ang history sa una when we try to trace back to the previous civilization. So as you can see in your note here, as early as 3,500 before the Common Era, the Egyptians already began mining gold, silver, and copper. And by 2,200 before the Common Era, we have, as a human race, learned to combine copper and tin to produce bronze. Okay, so that is just another perspective on trying to sell the idea that we really have to consider understanding or the study of minerals nga anong kinahanglan sa nga kana bitong dili siya ma-consider gihapon nato as an obsolete na science. Now, as I've said earlier, we are going to discuss each of the properties that define a mineral. First is it's naturally occurring. So when we say it's naturally occurring, it is formed by natural geologic processes such as your weathering processes, but above that one, we have other processes which you will get to learn in this discussion. For example, we have, or they are formed from precipitation of your aqueous solutions. So maka-form tag minerals ana ilabi na kanang formation sa imong lime. And then also unsa pa may mga possible processes. So it could be crystallization from your magma and either underneath or out of the earth's surfaces. So these are just some of the natural processes which could create your mineral. So by this definition, you cannot consider any synthetic na mga materials as a mineral. Or if you try to create crystals grown in the laboratory, we could not consider that as a mineral because by definition, it must be naturally occurring. So as you can see also in this illustration, I have here a more like very like similar illustration, but the point that I'm trying to show in this illustration is this is your natural diamond, although of course by nature you don't see it like this kay kanang sa iyang natural good na form class kay medyo maot pa magyud ang naong sa dynamo. It has to be cut to show this luster na property niya. But side by side, you have natural and synthetic. So this natural diamond could be considered as a mineral, but this one will not be. Because as I've said, the first, more like qualification for it to be called a mineral is it must be naturally occurring. For second, you have the second na qualification, kumbaga, para matawag na to siya as a mineral in the geologist sense is it must be a solid substance. So only crystalline substances that are solid at temperatures encountered at the Earth's surface, with the exemption of mercury, because mercury is in its liquid state at normal na to or room na to nga temperature and pressure. So mao pud ni ang second gyud nato nga qualification, kumbaga, para matawag nimo na siya as a mineral. Dapat siya solid substance. And when it is solid substance, it follows that it must also have a crystalline, orderly crystalline, not just any crystalline, but orderly crystalline structure na makita nimo sa imo ang sample. Now, zooming in our discussion in orderly crystalline structure, because this will be very important later, especially class when you try to understand the crystal shape and habit of different minerals depending on the atoms involved sa ana nga specific mineral group. We have to understand that kini gyud isa ni siya sa kinahanglan sa isa ka mineral. Dapat na siya orderly crystalline structure. So that means to say that their atoms are arranged in an orderly, repetitive manner. Naagid siya more like pattern ba nga. For example, let's try to go back sa imo ang pinaka-common na mineral na atong ma-encounter is your salt. Now, this salt is your sodium chloride. As you can see here in this illustration, you have your sodium ion. Okay, your sodium, I'm talking about the atom. Sodium atom and then your chlorine atoms together. Kita naman na siya dira. So naagid siya specific na repetitive arrangement. So na po kay sodium diri then another chlorine. So isa gyud na siya sa pinaka say tawag ani katong ginaingon nato in our colloquial term na properties or kanang feature na dapat sa makita sa isa ka sample para matawag nato siya as mineral. So it's not random, but there is an order and repetitive pattern, just like this. Sodium, ano po ay chlorine, chlorine, sodium, 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 chlorine, 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 chlorine. So naagid siya yung mga specific na layers sa imoa. Now you will also get to learn in the succeeding discussion why certain atoms or certain minerals tend to exhibit different shape. So masabtan na to na, and maybe you will write a paper, scientific paper about it. Okay? Okay, depende gid po na siya sa imong mga atoms na involved or sa imong sample na mineral. Now, if you look into this one, this is, by the way, an example of obsidian. This is your obsidian. Kung imong lantawon ng obsidian class, let's try to check. First, is it naturally occurring? Now, of course, if you are not familiar with this one, but I guess from the look of it, you are actually having already a clue that this probably is more like coming from underneath. So this is naturally occurring. So no problem with that. Second is it sa ganito? Is it a solid substance? Solid ba siya? Yes, of course. As you can see, solid. However, if you try to look into the crystalline pattern of your obsidian, you have an arrangement of your atoms which are not arranged in a repetitive, orderly manner. So wala kay makita niya nga pattern nga makidira. So more like random arrangement lang na siya. So because of that, it failed in this qualification for it to be called a mineral kasi wala siyang orderly crystalline structure. So katog yun silang tulo ang atong dapat nato nga ma-satisfy. Now, more on the discussion on orderly crystalline structure, as you can see here, medyo bugbog yung kayo, no, ang atong example na sodium o chlorine na atoms na arrangement. But anyway, you will also get to see examples later, especially on the silicate mineral group na silicon and oxygen na pod ang imuhang nakamakitlantaw na to ang iyang pattern sa arrangement. So if you try to look into this one, of course, your chlorine, kung nakita ni mo diri class, na siya no? Okay, chlorine, syempre mas large siya compared sa imo ang positive na ion na kay sodium. So mao ni mong sodium nga atom, sodium, ano po kay chlorine, sodium, chlorine. So makita nimo. And by the way, I want you to follow the drawing that I'm doing. So if I'm going to inspect on this area here, these are all imuhang mga chlorine mo nga atoms together, kana siya. And then you have another layer of unsa man ni sila napod. Sodium na pod ni sila diri, chlorine na pod sila, sodium na pod sila. So ingon ana ang atong gipasabot when we talk of the orderly crystalline structure na atong dapat makita for it to be considered as a mineral. Now if you try to look into this lattice structure that you are seeing here, ang imuhang kuan repetitive gid siya class and orderly, so you can predict na unsa gyud ang arrangement nila. So parehana na napug kay lain nga arrangement diri, napug kay repetitive, so balik-balik siya nga arrangement. Unlike your obsidian, if you try to look at the structure of obsidian here, you don't have a well-defined pattern of the arrangement of the atoms in it. Okay, so last of the properties of minerals, I guess this is where I will end probably. Your mineral must be generally inorganic. So but pasabot, I guess you already had your more like introduction to, I think, inorganic chem in your grade 9, right? So when we say it's inorganic, kabalo gyud ta ana sa dali na lang na pagkaistorya no, kay we don't deal with kato inyong discussion sa una, kanumdo mo atong naamoy mga parent carbon chain, tapos naamoy mga substituent. So dili ingon adto ang atong structure na ginahuna-huna. So both pasabot, even though it's naturally occurring, it is a solid substance, and it has a well-defined crystalline pattern or crystalline structure. Pero pag organic na ganina siya class, dili nato na siya ma-classify as a mineral because your minerals are generally inorganic. So katong mga na ay carbon, hydrogen, oxygen as your base or kana imo abitang backbone, dili to siya ma-consider nato diriya. So take for example sugar. I will not answer this one, but I would like you to ask yourself if the common sugar, let's say our table sugar, if ma-consider ba nimo na siya as a mineral. So this is where I will end. Try to answer if our sugar or common table sugar para pareha ta og experience kay ilatatanan if ma-consider ba nato na siya as a mineral. Now first, of course, as a guide on how you will answer this one, you try to inspect each of this question. Is it naturally occurring? Of course, our table sugar kay gi-synthesize na nato na, no? But an alternative way of asking this question is it possible to occur in nature na maka-create siya og kanang sugar lang yun diretso out of, let's say, sa plant na to or sa mga like sugar cane nga ana. So daba yung natural nga pamaagi na maka-form kag sugar ana without more like the aid of humans. Now second, is it solid? Uy, grabe, no-brainer na nga question. Third, is it sa ganito, it must be naturally occurring, solid. Does it have an orderly crystalline structure? Crystalline. I know my spelling of crystalline is incorrect, so you just change that one. And fourth is, sa ganito, is it organic? So matest gid nako diri, inorganic, sorry. Matest gid nako diri kung nakadumdum pa ba mo sa inyo ang inorganic chemistry sa inyong grade 9. Okay, so this is where I will be ending my discussion, and for the upcoming discussion, heads up, as you can see here, medyo dali ra ni, no? Another property, by the way, of your mineral is it can be represented by a chemical formula. So in the representation of most of your minerals, you will keep on seeing SiO2, especially for your silicate groups as well as kana siya naagid na siya murag mao gyud na siya ang imong base nga kana bitang arrangement nimo na kay SiO2 then usahay na ala na siya yung mga trace nga elements nga you will also get to learn that some of the colors will be attributed to the existence of the trace elements sa imong SiO2. Okay, so again, I'm basically asking you of this question: can you consider your table sugar to be a mineral? So you just answer me on our face-to-face nga klase. Okay, so I already have something here. This is just to tease you of the upcoming discussion. So kana sila, and also we will have our own lab, mag-laboratory metabolic ani. So some of the properties, kana siya. So you will get to experience also or deal with some rock samples firsthand nga. Makita yun yung obvious kayo ang mga crystals nga naa sa imong rocks. Okay, so I guess this is where I will be ending my discussion and I will be seeing you on your face-to-face class on Friday.